Alright. Alright, let's do 12 for Mel, given that his sound wasn't working. That's also on video, so there we go. Where's 12? Oh, there it is. Alright. Oh, sorry, I was meant to do, sorry guys, you're right. I meant to do 12 today anyway, because I showed you two ways of doing it, didn't I? So, there's a second way to do it. Now, the first way we did it was by trial and error. Okay? Alright, we can do it by trial and error. Does anybody know what I mean by trial and error here? What does the ratio 2 to 3 is to 7 mean? 2 centimeters for the length, 2 centimeters for the width, 3 centimeters for the height, for every 7 centimeters for the length. You multiply them out and what you get? 42. Would you agree with that? Keep it in the same proportion. And what you get? Keep going. Think of a number, Owen. Pick a number. That's a huge number. Pick a smaller number. Double it. What happens when you double it, Owen?
4.
4, 6, and what you get when you put that into the calculator? 2,000? 1,000? 200 and? Thank you. Alright, that's great. Now, what happens if you go too big? What happens if I multiply it by, I don't know, 5 instead? So I'm doing 10 by 15 by 35. What's 10 by 15 by 35? Just plop it into the calculator. I think we're going a bit large, to be honest. So what is it? Use your words. 5,250. We've overshot the 2,688 mark. So let's try again. What else could we try? 4 times bigger. Why don't we try 8 by 12 by 28? And what you get this time? Yeah, do you know what, guys? I'll just stick with that method. That's as good of a method as you're going to get. Trial and error on this. The other method is really sloppy. I'll show you the other method anyway. What you do instead is that you turn them all into 2x, 3x, and 7x. Do you get what I'm saying? So it's actually, I'll signify a red x here. 2x, 3x, and 7x. X is like a scale factor. X is the magical number we multiply them by to get the actual length. Because we know they're in the race. We know they're in a certain ratio. 2x, 7x, and what do we call that? 3x. Okay. So what's the area of this one? What's the volume of this one we multiplied out? 42 x cubed. Yeah. And that equals 2,688. Divide 2,688 by 42, and what you get? 2,006. What? 64 exits. Now, what this means is what number when you multiply it by itself? 3 times gives you 64. You press this button here to find out. For those of you that don't know where it is, it's just here. Shift cube group. And the answer is 4. Everybody cool with that? Now multiply each side by 4. So 2 times 4. Here. 28. This one. And there's your answer. 8 by 28 by 12. That's not trial and error. That's a proper method, okay? Trial and error works pretty well as well, doesn't it? Alright, let's go to 14. So I've done 12, now we're on to 14. I think 14 is buried down here somewhere. Ah, there you are. 14. Now, okay, what do we have next, lads? He buys a block of gold, and it's 4 by 3 by 2. What's 4 by 3 by 2? What's the volume of it? 24 centimeters cubed. And what do we need to multiply that by to calculate its worth? Multiply it by 500. What do you get? 12,000 euro. Is how much that block of gold is? Oh, the units are getting mixed up. Alright, this is not going to be fun for you, okay? This is not going to be fun. Let's do this, alright? But everybody agree that's centimeters cubed? You need to do a conversion, and you guys aren't used to doing conversions, okay? Would everybody agree 1 centimeter is how many millimeters? 10 millimeters. 1 centimeter squared is the same thing as 1 centimeter multiplied by 1 centimeter. In turn, that's the same thing as 10 millimeters multiplied by 10 millimeters. So 1 centimeter squared is the same as 100 millimeters squared. Okay with that? Using that logic, what do you think 1 centimeter cubed is going to be? 10 millimeters multiplied by 10 millimeters multiplied by 10 millimeters. And what's that? 1,000 millimeters cubed. How much is 12,000? Oh. How much is 12,000 centimeters cubed then? Huh? I want to change 12,000 centimeters cubed into millimeters cubed. What do I do? If 1 centimeter cubed is 1,000, what do you think 12,000 centimeters cubed is going to be? Bigger or smaller? It's going to be a big number, isn't it? So, let's multiply 12,000 by 1,000. What do you get? How many zeros are we looking at there? 6 or 7? Is it? Let's find out. I never trust myself to do these on my own, so I'll see how many we have. 6, lads, 6 zeros. Only 7. Probably. No. That's how many millimeters cubed of gold we have. Now, how much is it to make one ring? 250. So divide this by 250, and that's how many rings we can make. That's great. Did you get the same answer? Yeah. 48,000? 48,000 rings? Okay. Ryan, what's the issue? Hi guys. Shh. I made a mistake there. I used the cost of the ring, which is... The cost of the ring is 12,000 euro. The area of the ring is 24. Thank you. 24 centimeters cubed. So 24 multiplied by 1,000 is 24,000 millimeters cubed. That makes sense. And what's 24,000 millimeters cubed divided by 250? 96 rings. Thank you very much. Sorry about that. Now, each ring is sold for 150 quid. So let's multiply 96 by 150. What do you get? Nice and loud. 14,400 euro. Do we make a profit on that, do we? How much did it cost again? 12,000. Take away the 12,000 euro you spent on the block of gold and we make 2,000. Does it just ask for the profit or does it want the percentage profit? Profit. Profit per ring. Alright, so divide 96 rings gives you 2,400. So divide 2,400 by 96. And we get 25 euro made per ring. Is that okay? Yes, Dara.
I did a 1 centimeter cube.
That's perfect. Did you get the same answer?
Yeah.
But then you did it perfect, didn't you?
Yeah, but I did it weird.
No, you just did it differently. And it worked. Do you want me to have a look at it?
That's fine.
You show me at the end if you want. But if you got exactly the same answer, it'd be highly unlikely that you made mistakes and got the same answer.
Yeah, thank you.
Right. What's the next one we're doing? 16? Quantity of uncooked dough is placed in the baking tray with square base of 4. So it's more like this. The diagram is a 2D diagram. If you ever want to do a 3D diagram, just draw a parallelogram. And then, what we draw here? Draw one of these. I'll use this to represent the dough. Is that okay? So what we'll do here? Control D. 1, 2, 3. Alright, there we go. Be handy. So there is, if you ever want to draw a 3D, it's just 2 identical parallelograms. Then you just join them accordingly. There you go, there's your uncooked dough. Alright? So it's 40, 40, and 6. Does everybody get that? Find the volume of uncooked dough. Alright, that's handy enough. 40 by 40 by 6. What you get? 9,600 centimeters cubed. The dough expands to a height of 7.5. Find the expansion in percentage terms. Oh. Percentage increase is what, guys? What do you say? What will percentage increase be? It'd be your increase divided by your original amount. Increase divided by original. I know that's spelled absolutely terribly. Okay? It's percentage increase equals increase divided by the original amount. Now what's the new amount if we replace this with 7.5? What do you think? 40 by 40 by 7.5, and Dylan tells me it's 12,000. I'm inclined to believe him. What's the percentage, what's the increase then? 2,400 increase divided by the original amount, which is 9,600. Multiply that by 100, and what percentage do we get? 25%. Everybody cool with that? Alright. Calculate the height of the dough in the tray if the dough expands by a volume of 16%. Alright. Let's get our original amount. What's our original amount again? Our original volume? And we're going to multiply that by 116%. What will that do? It will add on to 16% we're looking for. Where's the percentage sign? 11,136 centimeters cubed. Everybody happy with that? Now, how does that get formed? It gets formed by multiplying 40 by 40 by what? H. You what? Calculate the height of dough. I'm not done yet. Can I finish? Great. What's the volume of this one here, Owen? Length by width by height. So 40 by 40 by H. What is 40 times 40 times H? I think it's 1,600 H. Now do me a favour and divide 11,136 by 1,600. What do you get? 0.9. Is that the correct answer? Yeah, is that what I got? Yeah, Dylan, we agree, we're happy days. Yes? Yes. Dara figured out that you could just increase the original height by 16%. And you'll get the same answer. Yeah. It's not always guaranteed though. It will work in this case, but it was actually the length I increased by. The math gets more complicated, but in this case that will work perfectly. No bother. Happy days. Okay. I saw it worked on the method that would work for any situation. Okay. Now, is everybody happy with 17 now? Do we have 18 as well? Oh, thank God. Now, that's a parallelogram. That's not going to work. That's also not going to work. And we go for this. Alrighty. A swimming pool is in the shape of a cuboid with dimensions 50 by 25 by 2.5 deep. Okay, no bother. And what we're looking to do is we're looking for the volume of the pool in liters. Okay, let's do this. I'm going to convert everything to centimeters first because it's just easier. What's 50 meters in centimeters? Anybody? 5,000 centimeters. 25 in centimeters? 2,500. And finally, 2.5 in centimeters? 250. And what happens when you multiply all them out? Can anybody explain why did I immediately change to centimeters? Because I know 1 litre is 1,000 centimeters cubed. How many zeros is that? 6. So 3, 1, 2, 5, 0, 0, 0, 0, 0, 0 centimeters cubed. What can I do then? Divide it by 1,000, and we can turn it into litres. 3,125,000 litres. Something like that. Now, well good. The longest straight surface distance a swimmer could swim in the pool. That's unusual. Does that include underwater? Or do I have to stay on the surface? Nope. I'll tell you how to do it. Alright. I'm going to take my previous diagram if it's still here. Right? This one. Is everybody happy that this represents the pool? Okay, I'm going to show you 2 different answers. In an exam, I would do both answers. But I'd imagine most people wouldn't think to do most answers though. But we'll see what happens, right? Ready for this? Alright. Just let me do the question first and I'll take questions afterwards. Alright. I'm going to do 2 different things here. Okay, so this lad's going for a swim. It's a great question, actually. I think it's quite a big question. Now, I'm going to represent myself with a dot. Alright? So, this dot represents me. If I go across this way, how much distance is that? If that is the length. 50 meters. Everybody go with that? Now, would everybody happy that's the width of 25, yeah? What happens if I do a diagonal? Where I go from here to here? Still a straight line, isn't it? Why don't we use Pythagoras' theorem? And what do we do here? X squared equals 50 squared plus. Right, if it is, I don't know, is it? Bear with the answer. Is that the answer in the back of the book? 55.9? Is that the answer in the back? Now, oddly enough, because I teach Lebensart, right, you guys probably haven't done this yet, but I would argue that, what's the answer? 55.9. Straight. What's the longest straight surface distance? I suppose straight surface means you stay on the surface. So that is the correct answer. I was thinking, what happens if it goes from the top, goes underwater, and ends up at the very bottom? I think you can do that in Lebensart. We won't do that now. But that was what I was thinking. But I think surface means stays, not stays on the surface. Alright.